Hi guys, I'm back. I'm on starting a series of videos now. I promised to get back to the Philco 60 as basically for the time being a final video on it, which will be just basically doing alignment on it, and then I've got to show you the 38.7 playing and back in its cabinet playing. So I got a video yet to do on it, and I think I got a few other videos, but I will be getting back to those things. Probably tomorrow will be the Philco 60. We're going to do alignment, although I did run it and kind of touch it up by ear, but we'll do a VTVM alignment on it. Show you how to do it on, at least on a Philco 60. I have done alignment videos before on other things. So anyway, as promised, I'm starting a series. I don't know how many videos will be in this or anything. It all depends on how things come together. But on designing and building an audio amplifier. And for whatever reasons you might want to build one, whether it's a PA system, or you want to build one for a guitar amp, or if you want to build one to run your MP3 player into, I don't know. But anyway, we're going to go over some of the basic design aspects on this video. I'll go into them a little more in depth on later videos. I'm going to show you a schematic that I've drawn up. It's basically preliminary, and so it's missing some stuff such as a volume control, tone controls, and things like that, which you'll get later. And we'll discuss how the tube manual comes in quite handy when you're wanting to build something out of tubes. So first thing you'll notice here is what I've got showing here, and this is out of a RC17 tube manual. I got part of it over here. The poor manual is, the binding has pretty much came totally unglued. Let me see if I can zoom in here just a little bit. Two sections here, number 13 and number 16. I'll be using for an input tube a 6J5 for the very first amplifier tube. Then for the second stage amplification, and as well as the phase inverter, a 6SC7. So, and then for outputs there'll be two 6F6s and push-pull, class A1 push-pull output. So, what is this? Well, this here is information that's in the back of the of your RCA tube manuals, and resistance coupled amplifiers. So, which is basically what we're doing, and it's basically what an audio amplifier is. Other than resistance coupled, you can have a transformer coupled or a coil inductive coupling, but we're not doing that. We don't have interstage transformers or anything. The only transformer we'll have is the output transformer, so that we can match up to the speaker. But this covers several tubes. They range from the 1L4 all the way through and up to a 75 tube. Then it's got the charts that you go by. They'll give you some various resistors and capacitors, and there's some other information to it. But you take like the 6J5, if you got a B plus supply voltage of 90 volts, R sub P here is just the plate resistor that will be in the plate. It's in megohms, so 0.047 is a 47K. 0.1 is 100K. 0.22 is 220K. For the 90, it's the same thing for a 180 volt supply or 300 volt supply. Don't worry about if you don't have exactly that matching voltage, because you can go up to plus or minus 50% on the voltages and the resistors will stay the same. That's your plate resistor. Then you have the grid resistor, and this is for the next stage, grid resistor. So the next stage in there will be these resistor values here, again in megohms. So 0.047 is 47K, 0.1 is 100K, and 0.22 is 220K. If there was a secondary grid resistor, such as in a pentode or something like that, it would show up here, but this is a triode tube. Then resistor, basically what they're doing is they're using cathode biasing, so you have a cathode resistor. These will be in ohms, so 1870 is 1.870 K resistor. These are derived from just math formulas, so don't worry about trying to find an 1870 ohm resistor. A 1.8 K is perfectly fine. Any one of these resistor values can be plus or minus 20%, but it changes with depending on what kind of resistors you got in the plate and grid resistors. Then you got the capacitor that will be bypassing that resistor, the capacitor on C sub K or on the cathode. This gives you the values in microfarads. This is your coupling cap going to the next stage. Values in microfarads. This is the output voltage that'll be seen from across the RP grid or the plate resistor. The actual output voltage is shown here in volts, and then just the gain. How much gain did it have from input to output, voltage gain. So that's how you read the charts, and it goes for every different kind of tube. If there's a tetrode or pentode tube, then it will have a RG2 or grid resistor for that screen grid, and also a bypass capacitor for that. The 6SC7 is just a dual triode. All the values in here are basically per triode plate, per triode. The cathode is a single resistor, since it's got a single cathode but two plates and two grids. So that shows up in there. And then each one of the when you're back here with the 6J5, the grid resistor will be just two of them, one for each grid. Now, other information on this, it'll sit here and tell you see like circuit diagram 4. This says see like circuit diagram 1. It shows how they're hooked up, and that's back towards the front here, as well as what all these mean, these different abbreviations. They are listed here through right here, and explains all of them. Then they go in a general explanation of the circuit considerations. They're looking at a flat voltage output across a range from frequencies from F1 to F2. These are in the audio range, and F1 is extremely low frequency, about I believe it's 100 Hertz, and then F2 is above hearing range. So now figure diagram 1, and I'll kind of get that down there where we can look at it a little closer. Rotate here just a little bit. It's going to kind of change the way. Now I can do this. There we go. It goes in explanation of the circuit and the different values, but here's R sub K, the cathode resistor, C sub K, the cathode bypass condenser. You got your inputs here. R sub P, or that plate resistor, is right here. Coupling cap. Here's the next stage, grid resistor, R sub G, and then EO out. Now, on the other one it said go to number 4. Diagram 4 is shown here. Again, R sub K is a cathode resistor for the biasing. It does not have a bypass cap, and I'll get in that probably not in this video but the next video, explain why that's not there. We've got 2 C's, 2 coupling caps, because one goes to one tube in the push-pull, the other one goes to the grid of the other tube in the push-pull. We have our plate resistor for one, R sub P, plate resistor for the other plate, R sub P. These will be the same size, whatever is listed in the table for what voltage of supply voltage, excuse me, that you're supplying the tube with. And grid resistor, that will be for the next stage or the output stage. And again, grid resistor here, R sub G. These are basically 2 same sizes. Now, in order for the phase inverter to work, we have to invert the phase. So one triode is feeding directly in, just a direct connection, just like any other type of amplifier and coupling and everything. It feeds directly to one of the 6F6s, which is what I'm using, output tubes. The other triode is going to feed the second tube, but it has to be inverted, its phase. And the way it does that, it's going to pull some power from the first triode. It's going to pick up that signal and feed it back to the grid. Well, I can't just pull that directly, because then that's going to be, this first stage does have some gain, and it's going to throw off the levels of the signals going to the output tubes. So they'll be way mismatched in signal on the signal levels. So basically what they do is they got what they call point P here, where they've tapped this resistor. Now, you don't have to buy a tapped resistor. You basically use 2 resistors is what you're doing. And they go in and tell you about how they want that done. Basically, you take the grid resistor that you're supposed to have here, and then you take whatever the gain is on this tube. The other resistor, the other part of the tap, will be 1 over whatever the gain is. It'll be its size. So if it's like, let's say, a gain of 20, then that tap will be down here, this amount of resistance here will be 1/20 of the total resistance. So it'd be a lot smaller resistor. So since you're using 2 resistors, the top section here will be just your standard grid resistor size, and then the next one would be a much smaller, 1/20 of that size and value, or as close as possible. What that does is allow it to reduce the signal strength coming back in this tube, and so that the 2 tubes will be roughly balanced, or should be balanced, and then they're feeding a balanced signal out. And I'll go in depth into that a little more on that, on exactly how that works. Now, to move on to the rough schematic so far, and I'll back this out. Whoop, wrong way, sorry. Some, and we'll lift it up a little bit so we can kind of get centered and try to zoom in just a tad bit. Alright. Okay, we have our input here, and however you want to hook that up, whatever you want to use for connection to actually physically connect to the amp. I just drew a couple circles. Put about 100K resistor here for the grid resistor of this first tube, the 6J5. Now it's not in that chart, but 100K is a fairly good value. Basically, you can just follow, like if you did have another 6J5 in front of that, and just go from that. But 100K is well within a operating range for this tube. We've got 2.2K, which is a close value to what they were requesting for a cathode resistor, and a 2.2 microfarad bypass cap, and 0.01 for the coupling cap, microfarad. On the next video, I'll go over how to get that value, or get something close to, to get the value, because it's not going to be the same as what's in that chart, but I'll explain how you figure it. Then that basically is your first tube. We have a 47K plate resistor. We feed into a 0.01 microfarad coupling cap to a 220K grid resistor for the first grid on this tube, and that has a 1.2K, which is a real close, it was like 1170 ohms, so 1.2K works great for the cathode. Biasing resistor, this feeds out to 0.05 and feeds on over to the grid of the 6F6. The other plate or the other grids right here, we also have 100K for the plate resistor for both these plates, so they're both same size. They feed off to B+. When you get here, this signal splits, goes through a 470K grid resistor, then a 15K back to ground. That splits off the signal, make a voltage divider so that I can have the proper size signal coming here. That's works out. This tube here, it actually works out to be 1/33, so that's 1/33 roughly of 470. It's actually up 500K, but close enough. And then that will feed out to 0.05 again to the second tube, which has got a 470K going to ground for its grid resistor. And then these tubes are to operate in Class A. The tube, following the tube manual, says 320 ohm cathode resistor. I have not put a bypass cap on this. You can, but I'll get into that again on the next video of why I'm leaving it off. Also going by the tube manual with the approximate plate voltage and screen voltage for the Class A. Push-pull works out that my screen will happen to be dropped down some voltage, so about 2.4K will work fine for dropping that B+ down to the screens. And then of course this feeds into, I just got part of the transformer showing here. It feeds in the output transformer. Standard center tap goes back to B+, and then each side goes the plates. And you don't need no plate resistance because it's the impedance here that develops that plate resistance for the 6F6s. And then down here we just got a basic power supply. Be a 5Y3 for the rectifier tube. About a 10 microfarad cap here. A choke here, which basically is the field coil on the speaker. It drops about 87 volts, about 1000 ohm. So DC resistance in, and about 22 microfarad here, and then that just feeds off to all these B+. I didn't show all the grounds in here. I just showed it here because I wanted to show you that, basically all grounds connect together to make up a complete path. And I wanted to talk about this. Grid resistors, for one thing, as well as plate resistors, they're both load resistors. The plate resistor is the load for the plate. The grid resistor is basically the grid load. Some books, well, non-engineering books, try to call it a grid leak. Grid leak is something totally different than what this resistor is doing. Grid leak resistor works with a coupling cap. The two work together with an RC time constant to actually develop the grid bias voltage needed for the tube from a signal coming in. And I went over this once quite a while back. I probably should go over it again about how that actually works. But what this resistor is actually doing is you feed a signal in here. You've got what you might call the hot lead here and the ground lead here. That signal comes through and goes through this resistor back. That's the complete path. It develops a voltage drop across that resistor. That voltage drop is what the tube actually sees. If that resistor wasn't there, that tube wouldn't see anything. You have to have a resistor to have a voltage drop. You have to have a voltage drop to actually show the signal. You're trying to show some sort of a sine signal, AC signal. You've got to have a voltage drop to develop this. You've got to have something to develop it over. And resistors work really great to do that with. That's the purpose of the plate resistor. It develops the same thing. There's a voltage drop. It goes through it and shows up this sine wave. That's impressed to a parallel resistor here, basically in parallel in the circuit. If you follow this all through the power supply, it comes back basically in parallel, but it impresses upon this 220K, and that sees the signal, and then that's fed in to the grid. Different sizes of resistors can actually amplify it. This coupling, this RC or resistance coupling here, actually can amplify the signal a little bit because there's not much current loss between these two. So if I got a 47K here and a 220K and I'm feeding current through the same amount of current through either one of the two resistors, pretty close, there's some difference, I'm going to get pretty close. I'm going to get a little bit greater voltage drop on this. So it does amplify, not as much as it looks, but it does some. And that actually acts as the total amplifier's voltage gain. So when you're going back to those charts, the charts show that in there. When you look at them, they show different resistor values, and when they're showing the different resistor values, you see a different voltage gains. It's not huge, but it is a slight difference. So kind of show you that. Say on the 6J5, it's a low voltage gain tube. Makes great for scooted over. Let's see if okay, we're in there. We got 13, 14, 15 here, all 90 volts for our supply, and coming down to, so we range between 13 and 15 on our voltage gain. And that's ranging from different sizes of resistors, the plate resistor versus the grid resistor, the next stage, which changes how much gain we're getting So as the resistors increase in value, the gain increases in value. As they also increase in difference in value, the gain increases a little bit. Again, this tube, a 6J5, is a low mu tube. So it's a low amplification tube, about 20. The 6SC7 is actually a much higher gain tube. So we're running like about the highest over here is 16. Run from 13 to 16. This runs clear up to 49. If I can get it on there. Let's see. Make sure I'm getting on the right one here. There we go. Back out just a little bit. So it'll run down to about 49 is the highest, from about 13 depending on how much plate voltage we have. So it's a little bit higher. It's a high mu tube, but it also shows the same thing. The differences in the sizes of the resistors and the size of resistors themselves makes for a higher gain as the difference becomes greater and the values become greater. So basically, now I'll probably put, let me back this up. What I'm going to do is build this thing up just as it is here, basically, and then tweak it. First, see if it works. It may not even work, but if it does, then we'll tweak it. And then once we're done with the tweaking of it and getting it where we have the maximum, the best gain out of it as possible within the regards of the tubes I'm using. They all test good, but they are on the lower end. They're used tubes, so they're on the lower end of the good. They're not, like new old stock tubes. But once I can squeeze as much as I can out of it, then what we'll do is we'll start playing with volume controls and tone controls in here, and maybe even doing some tone corrections on the output and stuff of that nature. So that'll be upcoming videos. Basically, what I've done so far is, as far as actual physically doing anything, is I've gotten me a chassis. It's an old chassis that I had went ahead and painted up. It was a little rusty here a while back. Stripped her down, left just the sockets in it, and got a old Philco power transformer that should be good enough for what we're wanting to do. Got it fitted in. I had to do a little cutting, but it's gotten fitted in. There's still more cleaning that has to be done on this. This chassis, I kind of like it because the tube sockets and some of the other terminal strips and stuff in it are not basically like your standard sockets or anything where you've got a hole that you run your wire through, which I was going to only attack anyway. So wrapping it, these come up and they have a split, and you just stick the wire down in and solder it. And so that way I can basically kind of breadboard it up. I'm not locking anything solid. I'm just going to tack everything together so that as I need to make changes, I can make them real easy without getting into a lot of trouble, a lot of work. But it's going to be based off of this. I thought I'd try to keep it looking something of old, so I went ahead and I got to clean this off of here because that is not what's in this. I restuffed this cap with the 10 and the 22 microfarad caps, and then I'll just polish this up, and when I do that I'll get rid of the ink on there. And I figure either on one of these or possibly on one of these, probably one of these here, somewhere in this area, I can mount the cap. So either that, I don't need all 6 tube sockets. There'll be 5 tubes in it, so I could probably actually even pull one of the tubes out. May have to increase the size of the hole and fit this adapter plate in there so I can mount the filter cap. And got a speaker. I got a little work to do on the cone, and an audio output transformer. It's good. It's a little dirty. I still got to clean it up. I went looking for it today and found one that is good and it will work. What this came out of, I actually had 2 6F6s in push-pull. So it's all ready to go up on that. Now, I showed you tube manuals and everything else. The other parts of the tube manuals, you can look up individual tubes, such as like the 6F6s. And we talked, I talked a little bit about those, and basically was talking about that, say that cathode resistor 320. Well, if we flip the tube manual, and like I say, the binding's bad. It's kind of came unglued, and if I can get here and move this manual over a little bit, too much more of it falling apart. Yeah, we're going to move this up just a little bit because when I zoom in, alright. Now, the 6F6, of course, when you look in the tube manual, you're going to see, they'll show you the pin out. They'll talk a little bit about it and stuff, and then they'll move on. They start giving you the basic ratings. They tell you the heater voltage, which is 6.3 because it's a 6F6. First number 6 tells you the heater voltage. And then it tells you the current, which is, and this is when it's hot, is 0.7, 700 milliamps or 0.7 amps. They then give you maximum readings for a single tube class A1 amplifier, and then they go through a couple typical operation of some different voltages and different types of biasing, cathode bias and fixed bias. Well, that's not exactly what we're interested in. We're interested in push-pull, so we'll zoom a little more into that. And there we go. So now we have here typical operation push-pull class A1 amplifier. Some tubes will have for different operations, such as AB1, AB2, even B. On this RCA manual with the 6F6, their main suggestions either single tube or class A push-pull. But they go through here. You have your plate voltage, your grid number 2 or screen voltage, and then they've got fixed bias and cathode bias. You're using fixed bias, you set it up at minus 24 volts. Cathode bias, we have the cathode resistor, 320 ohms. And then goes through here and tells you the different currents. First is the current at 0 signal on plate, current when there is full signal, 0 signal current on the screen, and full current at full signal. And then they tell you effective load resistance plate to plate is 10,000 ohms. That's you get from the audio output transformer, primary winding. And then they give you total harmonic distortion between the two, In this case with cathode is 3%, and output wattage is about 10.5 watts. So that's what, and from this you can find, information such as, the 320 ohm resistor and very basics. Don't worry so much if your voltages are not going to be exact. This will work fine within a great deal of room of several volts. So if your voltage coming out of your power supply is going to be lower, which in this case will be, the 320 will still work just fine. But we'll be tweaking it probably and doing some things like that. We also play with putting a cathode bypass capacitor on that resistor and not putting one on. We'll try it both different ways, see how, if there's any differences in both gain as well as any differences in distortion. So anyway, one other thing. Now I've got a couple manuals that I've got. I got a RC14 and an RC17 that's actually in print form. 14 is actually in better shape. But there is a website that I will put in the description that you can go to. It's www.nj7p.info, but there's a lot of information on that website. You can also go there and look up tubes. You can just click right in a tube and he'll give you the information. But if you want some tube manuals, he's got, as far as RCA goes, he's got from the earliest one, which is number 10, all the way up through 1975, which is number 30. He's got all of them. You can freely download them, and you can have them on your computer, put them in a folder or something like Tube Data or anything, and give you some. Let's see if I can pull that up on the screen and show it to you, and that way you can see it. Some of the different manuals he's got. He's got more than just RCA. Let's see here. Kind of zoom a little bit into here, and we're just going to kind of move the. But I'll put the in the description of this video. I'll put the this where this comes from, the website. But he goes from, he's got Telefunken, Cunningham, RCA, Western Electric, Kenyon, amateur tubes, Raytheon, some Raytheon manuals, Taylor tubes, and Sylvania, some of theirs. The list goes on. There's several in here. Like I say, his RCAs go from 10 all the way up to 1975, which I believe might be the last one, or might be one more beyond that, but anyway, that's number 30. And you can download any one of these, or all of them if you want, to to have, and then you have all this information I was showing you. It'll be on your computer. Just open it up, and they're all PDF, so Adobe, and so you can just look up whatever you want to look up. So again, I will put that in the it's www.7j or j7p.info/manuals/tube _manuals.php. There's other information. He's got other books and other stuff on here. He has an index of military manuals, description of the military manuals, comprehensive listing of military manuals, intel manuals by order number, intel manuals by type, SEBHC manuals, listing of radio books, and listing of tube manuals. And if you actually go to his site straight on, he covers at www.nj7p.info is where you'll find, you can go to tube PDF files or the tube SQL database where you just plug in the tube number and it'll look it up. And then of course you can get to your manuals here, and there's some other stuff here that you can look up. So anyway, I'll put in the link to the website, and so that you can download your own tube manuals if you haven't already, or if you don't have any. So I think that's about all I've got. The video, as usual, runs long. So on the next one we'll go over more in-depth stuff, and I'll have probably a lot more constructed. Again, tomorrow I'll be doing a video. Should be getting it up tomorrow on the Philco 60. So those have been waiting on that. I'll be showing a video on that. And so I don't think there's anything else I got to say. So I want to thanks to my new subscribers, and thanks for your comments, everybody who's commented. I am going to probably, after this is uploaded, get on there and try to answer some of your comments. There's some questions and stuff I need to get to. And so if you like this video and stuff, give it, the thumbs up. And if you're new to my channel, you haven't subscribed already, and if you like stuff dealing about theory and about working on radios and TVs, restoring them, and test equipment stuff, mostly everything is tube, then please subscribe, and that way you'll know when the new videos come up. So I want to thank you all for your support and for watching, and I'll see you guys on the next video.